Hey everyone, I am Hemish and welcome back to Hemnuts, where we break down the machine learning in the simplest and most friendly way possible. Today we are diving into the one of the most important chapter in machine learning, preparing to model. This is the stage where you can understand your data, clean it and explore patterns and get everything ready before training. Trust me, once you understand this process, building machine learning models becomes so much easier. So let's take it slow and simple and step by step, let's begin. Preparing to model. When we talk about the preparing to model, we were basically talking about all the work that happens behind the scene before the machine learning models start learning. This includes the cleaning the data, understanding what each attribute represents, checking for mistakes, and make sure the data is actually useful. Think of it arranging ingredients before cooking. If the ingredients are wrong, the final dish will never come out tasty. Same logic here. Preparation flows. The first part of preparation flows is understanding the type of data you have used. Is it numeric? Is it text based? Is it mixed? This helps us to decide what kind of processing is needed. Then we explore the data to check it quality or values missing. Are there are errors? Does something looks suspicious? We also check our how features are connected to each other. We also check our what patterns exist and whether some attributes depends on others. This yearly exploration gives you clear picture of the dataset. Next, we look for issues, missing values, weird values, or outliers, invalid entries. If something looks off, we fix it before going forward. Then comes to pre-processing steps like a dimension reduction and feature selection, where we reduce the number of features to keep only the useful ones. This keeps the model fast, clean, and efficient. Data partitioning and model selection and cross-validation. Before training, we dive the dataset into a training testing parts. This helps us check whether our model is actually learning or just memorizing. After that, we choose the right model depending on the type of data and the kind of prediction we want. And finally, we use cross validation, which basically tests the model across the different slides of data to make sure the performance is consistent and reliable. Performance evaluation. Once the model is trained, we need to evaluate how well it's doing. For classification tasks, we use tools like the confusion matrix, which shows the correct and incorrect predictions. We also use the ROC curve and similar visualization tools to understand the trade-off between accuracy and errors. This helps us judge whether a model is trustworthy. Performance improvement. If a model is not performing well, we can still improving it. We can tune the hyperparameters, try ensembling methods or using bagging and boosting techniques. This method combines multiple models or adjust the parameters to quiz out better accuracy and reliability. Type of data. What is dataset? Before talking about the data types, let's understand what the dataset really is. A dataset is like a collection of information arranged in rows and columns. Each row represents a one record like a student details. Each column represents a one attribute like age, marks or height. Understanding this basic structure is the first step to understand your data. Qualitative data. Qualitative data is a descriptive information. It tells you qualities or categories but not numbers. For example, color, brand, names, emotion and so on. You can describe it but you can't measure it with numbers. Nominal data. Nominal data is a type of a qualitative data that represents the labels or names. There is no order or no numeric meaning. For example, blood group, gender, nationality, you cannot sort them meaningfully. They just represent categories. Ordinal data. Ordinal data is similar to the normal data, but here the values can be arranged in a meaningful order. For example, satisfaction levels like very happy, happy, unhappy, or grade like A, B, C. The order matters, but the difference between values is not fixed. Quantitative data. Quantitative data is all about numbers, values that can be measured and compared. Marks, height, age, weight, this all falls under the quantitative data. We can perform mathematical operations on them, which makes them very useful for modeling. Interval data. Interval data is numeric data where you can measure difference between values. For example, Celsius temperature, the distance between 20 degrees Celsius and 30 degrees Celsius is the same as between 30 degrees Celsius and 40 degrees Celsius. However, it does not have absolute zero. Ratio data. Ratio data is the most powerful type of numeric data because it has all properties, order, equal and spacing and turn zero. This means you can add, subtract, multiply and divide. Example includes weight, height, salary, distance. Exploring structure of data, numerical versus categorical. Most datasets contain a mix of numerical and categorical values. Numerical values are measurable, while categorical values represent the labels or categories understand the help us to choose the right preprocessing steps. Exploring numerical data. To explore numerical data, we usually look at the visual patterns through box plot and histogram. This gives us a clear idea of how values are spread, whether they are outliers or how symmetric or skewed the data is. Box plot and histogram. Box plot helps us quick spot about the minimum, maximum and quartile and any outliers. Histogram shows how frequently values appear within the same physic ranges. Together they give you a solid understanding of your data distribution. Central tendency. Mean. Example. Mean is the average of the numbers. You can add all the numbers and divide by the count. Using the example 21, 89, 34, 67 and 96. You calculate the total and divide it by 5 to get the mean value. Median. The median is the middle value when all values are sorted. In the sorted list 21, 34, 67, 89, 96, the middle value is 67. Median is especially useful when the data is extreme outliers. Why mean and median both? We look at the both because they behave differently. The mean gets affected heavily by extreme values, but the median stays stable. So if a mean and median differ a lot, we know the data is skewed. Understanding the data spread. Why data spread matter? When mean and median shows big difference, the data is not evenly distributed. To understand this in the more detail, we look at the full range of values, not individually, but through graphical summaries and spread matrices. Distribution understanding. We use the distribution plots and spread matrix to understand how data is arranged. This includes checking how far values lie from the center and whether the data is tightly or widely spread. Exploring categorical data. Limited options. For categorical data, we do not have as many visual tools. We mostly look at how many unique values exist and how often each category appears. Car name example. In an auto MBG dataset, the car name and column name contains many unique names. By listing them or counting them, we understand the variety present in the data. Exploring relationship. Look at the one attribute at a time is helpful, but relationship between variables matter even more. We use scatter plots to understand how one's affected another. For example, weight versus mileage often shows a clear trend. Data quality, importance. The quality of your data plays a huge role in how accurate your model becomes. Missing values, incorrect entities, and outliers can pull the model in the wrong direction. Causes of issue. Data problems can arise from the incorrect sampling, human mistake, and sensor errors, inconsistent data collection. Understanding the root cause can help us fix the data properly. Handling outliers. Outliers are values that stands out how far away from the rest. They can be errors or natural extreme cases. Depending on the situation, we either keep them or remove them or adjust them. Next, we going to see the handling of missing values. Missing values are common. We usually fit them using a imputation, mean, median, and mode. Depending on whether the data is numerical or categorical. Data preprocessing, dimension reduction. This helps us remove unnecessary features so that model becomes a faster and more accurate. Techniques like a PCA and SPD transform high dimensional data into a cleaner and lower dimensional form. Feature subset selection. Instead of transforming features, we can directly select only most important ones. This helps the model focus only on the attribute that truly matter. Thank you so much for watching. This is Hamish from Hemlands, and really I hope this video made the concept of data preparation clear and easier. If you enjoyed this explanation, do not forget to like, share and subscribe and drop your suggestion in the comments.